Guys, Smiley here. So today we will be learning about quadratic equations. So what is a quadratic equation? We know about some general equation, right? 5x plus 7 is equal to 9. Then x plus 1 is equal to 2. And the right, x plus y is equal to 8. Right, these are some equations which we have encountered up until now, right? But there are more equations, more types of different types of equation. One of them is quadratic equation. So what is a quadratic equation? So a quadratic equation is a type of an equation which can be written in this format. Okay, so let's look at an example first. If I have, say, x square plus 2x plus 4 equal to 0, this would be an example of a quadratic equation. A quadratic equation is defined in such a manner such that the highest power of the x value or the unknown value is square and followed by a linear value, which is 2x plus 4 in this case. And if we look here, this is the general equation, ax square plus bx plus c. In this, a, b, c are the coefficients. Okay, now let's look further into. So take a look at this equation. Let's say I have to find the value for x in this case. Okay, so now the general method what we apply, that isolating x and doing all that, it won't work here because you can't really isolate x in this case. So we apply a very different method for solving this altogether. So the method is something like this. Let's say I have a number 6. Okay, now if I ask you factors for 6, what are the factors of 6? The factors for 6 are 2, 3, 1 and 6 itself. Now if I ask you, is 2 times 3 equal to 6? You will say yes, definitely 2 multiplied by 3 is 6. So we use this idea and apply this right here. What we do is we try to factorize this equation or break it out into product of two such things such that they equal to 0. Okay, so how do we do it? First, we look at the middle number. The middle number is 5. Now we have to think, now what number when added together will give you this minus 5 and multiplied together will give you plus 6. Now there are two such numbers, minus 2 and minus 3. Okay, because when you add minus 2 and minus 3, you will get minus 5, and when you multiply them you get positive 6. Okay, so it's just looking and it's just thinking. Okay, so now that we know what is our two numbers, what we do is we break this minus 5 into these two numbers. So this will look like something like this. So x square minus 2x minus 3x plus 6 is equal to 0. Now what we do is we group them. Okay, and we take the x common. So from here this will become x bracket x minus 2. Okay, this will become minus 3 bracket x minus 2 equal to 0. Now minus 3 multiplied by minus 2 is equal to 6, which is why in the first scenario I did minus 3 and minus 2 and asked you which two numbers multiplied together would give you positive 6. Okay, now here we can see that the brackets are equal. Now we can take them common. This will become x minus 3 x minus 2 is equal to 0. Now if you did not understand this, the step between this and this, think of this something like this. Let's say that x minus 2 is equal to a for this case, and this is nothing but ax minus 3a. Okay, we can take a common and this will become ax minus 3. Alright, therefore a was what? X minus 2. So hence this value came x minus 3, x minus 2. Okay, now moving further, now this is a crucial part, and the reason why I had asked you if 2 multiplied by 3 is equal to 6, these 3 are factors, right? Now look here. Now this is 0. Okay, it is saying that a some number, right? This is some number, right? And this is some number. When these two numbers are multiplied with each other, they give result 0. Now when can this be the case? There is only two conditions. Either this is 0, this is 0, okay, or both are 0. It doesn't really matter. If both are 0, then it doesn't really matter. If one of them is 0, because automatically other one will be 0, right? So what this means is that if this is 0, if x minus 2 is 0, x would equal to 2. But if this was 0, means this factor was 0, x would equal to 3, and this is our solutions. Okay, so for this equation we get two solutions. X is equal to 2 and x is equal to 3. But now here is something, but this is really inconvenient, right? If you think about it, you will always have to think of some two numbers which add together gives you 5 and multiply together gives you 6, or some number, right? So what we have done is we have devised a formula. Okay, we also have a formula for this. This formula is known as the quadratic formula. Alright, and now we will be discussing about that. Now we are back to our original general equation for a quadratic equation, right? So this is the general equation for any quadratic equation, and using this, what we are going to do is we are going to devise a general formula to solve a quadratic equation. Okay, so the formula goes like this: x value is always be equal to minus b plus minus square root of b square minus 4ac upon 2a. Now here something to note. Okay, here a, b, c are all the coefficients. Okay, they are the coefficients of x. Okay, so they are coefficients of x. Okay, now they are coefficients, okay, and all, but is there some conditions which we have to be careful about? Well, there is some conditions. So the number one condition is that a should either be greater than 0 or it should be less than 0, but it can never be equal to 0. Okay, if it's equal to 0, right, this will just become 0 and it will be a linear term, right? Then it will be just be a linear term which would be, we would be finding the value by using our normal methods. Alright, so it cannot be 0. Now there is something, one more thing which we must remember. Now I want you to take a look at this. Alright, this at the hand side looks nothing special, but had something very unique. This is known as the discriminant. Alright, the value b square minus 4ac is known as discriminant, which is denoted by d. Now what is this discriminant, right, and what's its use? So let's take a look at this. If your d, which is the discriminant, is greater than 0, okay, if that value is greater than 0, what will happen is your roots, okay, we call the solution for the value of x in a quadratic equation roots. Okay, so x value, okay, the value for x is roots. Okay, we call them roots. Okay, now what I was saying was, if your discriminant is greater than 0, then the value of your x or your roots will be real. Okay, it will be real if your value or this d which is there, it's equal to 0. What will happen is your roots will be rational, okay, will be rational and equal, which means that both the root will be same, means you will get this one value only for x. Okay, one value for x. And if your root is less than 0, your if your discriminant here, this discriminant is less than 0, your roots will be imaginary. Okay, imaginary. What imaginary basically means is that your square root will have some negative value, okay, some negative a, okay, and this is denoted as such as this square root of a, and we put here I, okay, where I is equal to square root of -1. Okay, but that's not really important, right? We won't be really dealing with imaginary. Everything what we are considering is in real, okay, they are real, okay, so or like this. Now in this also, in this there are some categorization which we need to be aware of. See, if your d is a perfect square, okay, if it's a perfect square, that is, if this is like this square root of a square, what this means is that your a, please listen to this, your a will be rational. Okay, it will be a rational number. Okay, it will be a rational number provided that every one of them is rational. Okay, means that it must not be something like root 2 or root 3, something like that. Okay, otherwise it will depend, but it will be rational. Okay, it will be rational most probably. When if we are dealing with integer coefficient, it will definitely be rational. Now, but yeah, and here is the thing. If your root d, this d which is there, it's a prime number, then it will always be an irrational number. Okay, so the roots will be real. Okay, it will be real. Now take a look at this. Now if I ask you what is the nature of the roots, okay, what are the nature of the root, means how is the discriminant behaving. So how will we solve this, right? We know the value, right? We had just recently done this question. So but if I ask you the nature of the roots, we will use the b square minus 4ac method. So here b square is what, 5, so this would be -5 whole square minus 4 AC. A is what? A here is used and there is nothing, so 0. No, it's 1. Okay, this is 1. Okay, coefficient, if it's not given like this, it's always 1. Okay, because 1 multiplied by something is always that something. So this is 1, and here we have positive 6, so 6. So this will become 25 minus 24. Okay, so d is equal to 1. D is equal to 1. So what this means is that the roots are rational. Okay, the roots are rational and real, you can say. But till here it's understood. We are not required to write that real, because obviously if it's rational it falls under real. So yeah, that's that. Now take a look at this question. I wanted to pause the video and attempt this by yourself. Okay, I will be going ahead. So the question is asking us to find value for k. What we are given is the roots are equal. When the roots are equal, that means their discriminant is equal to 0. Okay, so what this would mean is that k square minus 4 1 3 is equal to 0. So what this means is that k square minus 12 is equal to 0. Therefore k is equal to 12 root. Alright, but when we put square root sign, we have to be careful for plus minus root 12. Okay, so this is going to be our final answer. So this is the value for k, plus minus root 12. Alright, now we will look at some coefficient relations. Now in the formula, x equal to minus b plus minus square root of b square minus 4ac upon 2a, which is our quadratic formula, we had looked at how x was being find out by using only the values in the coefficient. Now what we will do is we will use the same x and find some more relations between them. Okay, so the first relation what I would say is that we know that there will be always be two roots. Okay, for a quadratic equation, generally speaking, there are always two roots. Okay, let's call those roots alpha and beta. Okay, so let me just write one equation here: ax square plus bx plus c is equal to 0. So there are two roots for this, right? One is alpha, one is beta, right? There are two values for x, alpha and beta. Now there are two main relations. First is alpha plus beta. This is minus b upon a, and then there is the product. Alpha beta is equal to c upon a. Okay, where b, a, c, a are all coefficients of this quadratic equation. Okay, now if you want the proof, well, we can just add them, right? We can just add this. So if I add it, x1 plus x2, right? Or let's even better, let's just say alpha plus beta. So I know that one of the value will be this minus b plus square root of b square minus 4ac. Let's just call this d. Alright, we know that this is the discriminant, so I will just call it d upon 2a, and let's say the other value is minus b minus root d upon 2a, because I know this is going to be there, and this we can interchange, it doesn't really matter. So now what will happen is this will get cancelled, this will get cancelled, and minus 2b upon 2a will remain. We cancel 2's. Alpha beta is equal to some gamma. Okay, let's not even call gamma, let's call this p, and this as s. You know what will happen? If you know these two values, you know what you can do? In the quadratic equation, which is ax square plus bx plus c equal to 0, if you do not know these two values, okay, you can just put them in. So this quadratic equation is also can be written in this format: minus sx plus p equal to 0, where this is alpha beta p, and this is s is this alpha plus beta. Now why did minus came here? Let's see. So before that, we will have to see what was alpha plus beta. Alpha plus beta was minus b by a. Agreed, right? So what happened was this minus transferred over there, this became minus alpha plus beta upon b by a. Okay, and what happened was we just put that in, so this became ax square minus alpha plus beta x plus alpha beta equal to 0. Okay, and here is something which I wanted to show. Okay, now why did I take a common? Because a would go up and this a would go up, right? So it would have been, we would have just taken it common. Okay, and also we don't really show the a here. Why? Because a is generally 1 only in every case. Okay, we tend to divide by a, would give me, so you have to remember that x square for a quadratic equation, the b value, this coefficient is always the sum of the roots, and the last value, which is the c, is product of the roots. Okay, this will help you solve any type of question very quickly. So look at this equation. Okay, let us look at this problem and I want you to solve it. Okay, pause the video and please solve it. I am going ahead. Okay, so what we are given is the roots. Okay, so the root is 2 and 3, or the value for x is 2 and 3. Alright, so I want you to remember the formula what I had told you. Right, we know that x square minus sx plus p is equal to 0. Sx or s is the what? Sum of the roots. This is the product of the roots. So but just apply that. So x square minus 2 plus 3x plus 2 times 3 is equal to 0. Therefore our equation is x square minus 5x plus 6 equal to 0, and we have solved this extremely fast. Okay, so now let's look at a tougher problem. Okay, it's not really tough, it's a very simple problem. It just requires a bit of observation and substitution skills. Okay, so here you can see there's a fourth power, right? Now you might think that I am doing cheating. I taught you a little second power. How on earth are we going to do fourth? What I am going to say is that this is second power only. It's just that we are going to do some smart substitution here. So x raised to 4 can be written as what? X, this is the same thing as x square to the whole bracket square. Agreed, right? It is. We know that. What about it? So what about it is this. What I will say is that x square is equal to some t. Okay, now here is t. Okay, and here is t square, right? Because if I square this, this will become x raised to 4, right? So this became t square minus 20t plus 64 equal to 0, right? Now this is, isn't this just our quadratic? What I will do here is I will use the, now we will use the quadratic formula to solve it. So this will become 20 plus minus square root of b square. So 400 minus 4ac. So 64 times 4, right? It's just 1. This is 256 upon 2. T is equal to 20 plus minus square root of 144. This is nothing but 12 upon 2. From here we get T's two value. T is equal to either 4 or 16. But did the original equation ask T? No, it asks X value. So the value for X in this case will be x square equal to 4, x square equal to 16. Therefore we have obtained 4 values for x in this condition. X is equal to plus 4, x is equal to minus 4, right? X is equal to 4, and then x is equal to 2, x is equal to minus 2. Okay, these are the values which we have obtained. Okay, these are the 4 values for which we have obtained our solution. These are verifiable also. And also one more thing which we need to remember is, if look at the degree of an equation. okay, of any quadratic equation or any equation in general, polynomial equation, okay, if it for an nth degree, so right, if n is anything, right, it can be 5, 6, 7, some anything. If it consists of elementary operation as in plus, minus, multiplication, division, right, remember this, plus minus, okay, plus minus only generally, it will always contain n solutions, okay, n number of solutions. So that's it. Bye.